Least common denominators is like finding equivalent fractions, but with this very specific denominator. Usually it's something that's some kind of multiple of the two denominators that are there. But if they are the same, then we don't have to worry about it. Just that doesn't happen too often. So find the least common multiple of the following pairs. So for this, we can make a list. So 35 and 49, 35, 70, 105, 140, 175, 210, 245, and then 280. Let's see if that does it. 49. This one's a little different. 98 plus another 49, 147. Yeah, no matches. 196. No match. 245. There we go. That'll do it. Here I've got 245 and there's 245. That is our least common multiple. Now it's not the same multiple, right? 49 times, that was 5. And then 35 times 1, 2, 3, 4, 5, 6. That doesn't matter as long as we can find the same multiple of both. Now again, this is a pretty crucial skill when we're finding these common denominators, so it's important that you're able to do this. Find the least common denominator of the following sets of fractions. Assume no variables are equal to 0. Alright, well with that in mind then, what this means is that we can ignore the numerators. For now, okay? Because if we can get this skill down of finding the least common denominator, then we're in good shape. By the way, in the future, it's not even necessary that we find the least common denominator. We just need a common denominator in order to combine these. And we'll get into why that is here in a moment. This one looked like it had, or was supposed to have another number, but that's okay. 90, 180, 270, 360, 450. Let's see if that does it, okay? So 75, 150, 225. No, that would be, no, I'm adding the wrong number, dang it. 300, 375, and then 450. Yeah, that'll do it. So 450 would be our least common denominator. Now just to illustrate this, okay, what this means is that we'd multiply the 90 by, in this case it was 5. So we'd have to multiply the 11 by 5. And the 75 and the 11 would be multiplied by 6. And what that would do is it would change both the fractions so that we're comparing the same size pieces of something so that we could add and subtract these. We can't add and subtract fractions unless we have these common denominators, which is why this skill is so important. So 10, and then we'll do 6. So on this one, we got 3 numbers here, well, 3 values to look at. Here we've got 35, and again, we'll have to just kind of scale this up. 70, 105, 140, 175, 210, that should do it. And then the 30, 60, 90, 120, 150, 180, 210. The problem is that we got that y right there, okay? Now, we should consider the coefficient of the y, which is 1. It's just a phantom one that we don't see. Now, this would be really rough if we listed all the multiples of 1. So I'm not going to do that because 1 goes into any number. So really, this would go all the way down into 210 as well, right? Here's the problem, though, is that, yeah, like you said, there's 210y. So how do I make these other ones similar or the same with 210y? There you go. Just tag on a y with those. So it looks like our common denominator is going to be 210y. So So we have to be careful. If we see in a denominator that it has a letter, like this y here, it's not going to be a problem. We just have to tag it on to the other ones. But again, like we were showing, if you do it to the denominator, you got to do it to the numerator so that you don't change the value of the fraction. So we should acknowledge that this x has a coefficient of 1. So listing multiples of 1, we got 1 and 2. Well, that's already a common denominator with the 2. So we got the 2, and this one has an x, and this one has an x. So it looks like it's just 2x. What this means is if we were adding these together or subtracting them, we wouldn't have to change this fraction at all. I mean, if you really wanted to, you could say, I'm going to multiply these by 1, and then would multiply these by 2 to get those common denominators. And then we could combine them with subtraction or addition. But for now, the common denominator is 2x. Now, I want to point out on number 9, us math people, we're kind of tricksters this way. We put that 11x there, but it's in the numerator. So don't let that mix you up. That is not going to affect how we find common denominators. It's not even a denominator, so don't worry about that too much. So this one we got 7 over 13. The 6, some people view this as though it's not a fraction, but we can make it be a fraction as 6 over 1. So again, 1, if we found multiples of 1, 2, 3, 4, we could just go down until we get to 13. Now we have that common denominator 13. So hopefully that's not too tricky. It is a little tricky, but hopefully it's not too bad. Rewrite these as fractions with least common denominator. We're not going to reduce them because if we did, we'd just get these same values right here that we have, so there's no need for that. So we want these denominators to be the same, and it would be nice if one was a multiple of the other, but they're not, and that's okay. So let's look at the 6th denominator first. Multiples of 6, 12, 18, 24 is 30, 36, we'll stop there. 15, multiples of 15, well, 15 and 30. So, again, the thing I like about the list is it shows us what to multiply these by. So this is 1, 2, 3, 4, 5. So I have to multiply the 6 by the 5 to get that common denominator. But if I do it to the denominator, I have to do it to the numerator as well. So this gives us 25 30ths. And then the 15, I multiplied that by 1, 2. So I'm going to multiply the 13 by 2 as well. So this gives us a new fraction, 26 over 30. And this would be the two fractions. You can put an and there if you want.